Hi, this is Javier Encinas. Thank you for downloading your free 15-day trial of ASDIP. I'm confident that you will enjoy the evaluation experience. Today, I'm going to show you how user-friendly the software is and how easy it is to model and design your structure. In this case, I will model a cantilever retaining wall using ASDIP Retain. I will show the other products in future videos. Well, the user interface is very efficient and has been designed to model your structure the easiest way. It consists of controls such as buttons, text boxes, labels, combo boxes, radio buttons, checkboxes, etc. All these combined elements create a rich user interface. The typical calculation window, like this one, is composed of the menu bar at the top. Immediately below is the toolbar. From here you get access to many useful commands. Below is the working area. Here it's composed of two tabbed panes. The left pane is designed for the input data. The right pane is for the shows the results of the calculations. In this video, I will focus mostly on the modeling features of the software, and I will show the calculation capabilities in other videos. The input tabs are organized in a logical way: geometry, loads, materials, reinforcement, etc. It's a very logical way precisely to avoid confusion on where to specify a parameter. For example, in the geometry tab, you can enter the information on the dimensions of the retaining wall, the stem, and the footing. For example, let's start with the stem. The stem can be concrete or can be masonry. You can select the material here, either concrete or masonry. Check that when I change to masonry, all the interface dynamically changed accordingly to reflect the change. So from here you can input the stem height and the thicknesses and the footing and all that, the heel, the toe dimensions, the key, the soil cover. In other words, all the geometry of the wall can be generated in this tab. This picture here is very efficient and shows the meaning of all the variables involved in the geometry of the wall, so that you will never find yourself asking what this variable means. So everything is here. You know, the stem height, the backfill height, what is the toe, what is the heel, the soil cover, etc. All these are reflected here. In the loads tab, you can specify in the backfill tab the properties of the backfill, the earth pressure theory to use, either Coulomb or Rankine or equivalent fluid or at rest, and properties of the soil. In the surcharge, if you have any surcharge on top of the backfill, either live or dead, you specify that in here. Concentrated load, the same thing. If you have a vertical load concentrated at the top of the wall, you can specify it here. In this tab, wind and seismic, you specify the wind pressure on probably on a projection portion of the wall here. Or you specify the seismic coefficients to reflect the seismicity of your site. Note that when you change from tab to tab, the picture here below changes accordingly, reflecting the meaning of all the variables involved. Okay. In material, you specify the stem and the footing material properties, the concrete and the steel densities, allowable soil pressure, and so on. So it's very efficient as well. Here you would get some typical values of the friction coefficient if necessary. The reinforcement tab, it includes a series of controls to reflect the reinforcement of the wall. It has been designed to allow the user to specify the reinforcement of the members, so the stem, the toe, the heel, the shear key. A number of controls are provided here to completely customize and optimize the steel rebars. You may specify also a cut-off alternate vertical rebars here to to optimize the wall. It should be noted that whenever you change something in the input, the change is immediately reflected in the output. For example, let's see. Let me change here the backfill height to the full wall. Okay, you see that everything changes accordingly. For example, if I change the cutoff rebars here, it's going to be reflected here in the moment diagram. You see that it's stepped here, reflecting the cutoff rebars. If I eliminate the cutoff rebars, it is reflected immediately there. And like that, everything is reflected immediately in the calculation. The calculation consists of at a glance, where you can see the results in just one page, or in the condensed tab is some more detailed set of calculations organized by topic. You see calculations, overturning, sliding, the stem design, all that is in here. You can follow it. Or if you need a more detailed set of calculations with reflected exposed formulas like that, and code references to the for example, here is code reference to the ACI code. So everything is in here in the calculations. Graphically, you have also the stability check with organized by load case, and you can specify also the load combinations, or the stem design. This is the moment diagram, and this is the shear diagram of the stem. These are the forces and the pressures applied to it. The construction tab shows the wall rebars as a typical drawing. Also, the unit system, you can specify either imperial US units, kips, feet, KSI, or SI units, metric, kilonewtons, meters, centimeters, megapascals, or MKS, tons, meters, centimeters, kilograms over centimeters square. So all everything is customizable here. The design criteria can be specified here. You specify here the safety factors and the conditions that apply to the wall. Which is important to note is that you are in complete control of the design of your wall. You can change any parameter, any dimension, any load, any material, or any rebar, and see the effect of that change immediately in the results here. So you are in complete control of your design, but basically as what has been designed with that in mind, that you are in control completely of your design. So enjoy your evaluation period, and if you have any questions, any doubt, please let me know, and I'll be glad to help and clarify any questions. Thank you very much for your attention.